Hi, this is Sung. I'm the Principal and Director of Sky Academy, and in this topic we're looking at the geometrical applications of calculus. And what we have been looking at up until now is how the first derivative and the second derivatives give us information or inform us about the nature of graphing a curve. Okay, and in particular with the first derivative we've looked at stationary points and different types of stationary points like maximum, minima, horizontal points of inflection, and we've also looked at how the second derivative is an indication of concavity, and when basically the second derivative equals 0 and changes signs, it's where concavity changes in a curve. So we're going to put all of this together and kind of analyze how we can use the first and second derivatives as geometric tools in curve sketching by looking at a particular curve. And this is no particular curve in particular, but it's one that allows us to look at some features. All right. So the curve, let's call it y equals to f of x, just generically speaking. It kind of looks like this. Okay. Along the way, you will notice some key things. There is a minimum here. There is a maximum there. There is what looks like a horizontal point of inflection, and let's assume it is a horizontal point of inflection there. And obviously, as you go from a minimum to a maximum, there is a shift in concavity. So what you'll find is that the second derivative will equal 0 somewhere between there and there. Anyway, let's look at this curve and map it out. So what you'll notice is, well, the way we do this, the way we graph the gradient function for this is by first looking at the stationary points. Where will the stationary points be? So you've got a stationary point there, a stationary point there, and what we also know to be a stationary point there. All right. So this is what we call a point of inflection. So it's going to pass. And we know at these three turning points, these three stationary points, two of which are turning, one is a point of inflection. At these three stationary points, the gradient function will equal 0. So I'm going to put a little cross there, I'm going to put a little cross there, and I'm going to put a little cross there, right? And let me just make a little point about this. Just see there and there where the graph crosses the x-axis. They are obviously the roots of this curve. They're the x-intercepts of this curve. Just because they're the x-intercepts of this curve does not mean that they will be the x-intercepts of the gradient function. Okay, so let's just bear that in mind. So they're the new roots of the gradient function. And the way that we're going to analyze this is look along this curve at the gradients. What's happening to the gradients along here? Well, they're going in a negative direction, right? So they're going negative, 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 and then all of a sudden it hits 0, but then it continues going on its way being negative, right? So what's happening at this point is the graph is starting negative, hitting negative, and going back down into negative territory, okay? But it's going to come back up to 0, so it's not going to stay negative for too long before it hits 0 again, okay? And then it starts going positive, and it will go all the way positive up until it reaches that 0 again too. So you see here, it'll go positive, and then it'll reach this 0. And then it'll start going negative, but it's going to approach a stationary point, like it's going to approach 0, starting to flatten out. The gradient's going to approach 0 as x gets bigger and bigger. So what's going to happen is it's going to go negative again and then flatten out to 0. Does that make sense? And so that is what the gradient function will look like. And the gradient function we denote by f dash of x. So y equals to f dash of x will look something like that. Okay. Well, let's have a look at how this affects the second derivative function. Okay, so the way that this affects the second derivative function, again, we'll start by taking the we'll start by looking at the stationary points. So there's a stationary point there, there's a stationary point there, and there's what looks like being a stationary point somewhere here. Okay. So our new stationary points, so our new zeros for the second derivative function will be there, there, and probably roughly around there, right? So what's happening here is the function is going positive, 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 all the way to there, then it hits 0, and then it starts going negative again at that point there. So basically it goes positive to 0 and then negative. Okay? At this point it's a stationary point, so it'll hit 0 again, and then it'll be positive all the way up until it hits 0 here. So it's positive all the way until it hits 0, and 0 is where it crosses the y-axis. And then it starts going negative all the way down there, where it's equal to 0. And then what happens is the graph starts going positive again until it approaches 0. So this is your y equals to f double dash, or your second derivative function. But just remember what I said, where basically the second derivative function equals 0. What's going on is that there is a change in concavity in the original function. Yes? And that is exactly what you'll find here. At this point here, there is a change in concavity. Alright? Because this point here corresponds to this point here. There's a change in concavity. Alright? There's also a change around here, which corresponds to this point here, which is roughly around here. There's a change in concavity. See how you're changing from concave up to concave down? And there is also another change in concavity roughly there as you're going from concave down through to concave up again. Okay? And the key thing that I want you to notice is that concavity is changing where f double dash equals to 0. So there's also another point of inflection there. So these are the points of point of inflection, and that's what's going on in this graph. Thank you very much for watching.
Hi, this is Sung again from Sky Academy, and I just want to thank you for watching this video. I hope you found it useful and at times entertaining. If you want to see more videos like this, you can either click here for this video or here for that video. And you can continue to get videos like this from us by subscribing to our channel, and you can do that by clicking above, or if you're watching on a mobile, please tap below to access our great content and resources. Thanks again for watching. This is Sung signing off. Bye.